Okay, so what we're doing today is we're going to quickly go over, take about 10 minutes to go over what we did in the last lesson, which was exponential function and the quadratic one where Mr. Coe was hitting the cricket ball 500 metres up in the air. And we're going to start undirected graphs and networks, which is the last topic we have to cover. Now, the test is written in draft form, so Mrs. Galuzzo is looking at it right now, but I know what the finish line looks like. Okay, so we're not going to be vague. We know exactly what we have to get through. So, in this first part, we're just going to look at, the first one is the ball being thrown up in the air. Okay, such that its height is given by a formula. Now, what you have to look for is what the units are, because your answer has to have units. So, the formula will be given to you, and we know that this one goes up and goes down. And the question is, why do I know the ball goes up and down if the formula looks like 30t minus 5t squared? How do I know it goes up and down rather than going the other way? Say again? No, but there's a way of just looking at that formula and know that it's an upside down parabola. More information, please. You're on the right track, Riley.
30 minus 5 and 30.
No. Riley's on the closer track. Yep. Yeah. Because it's got the squared term is a minus, which means it must be an upside down parabola, which means it's going to start from somewhere, go up to a high point, and then come back to some other point. So in this particular question, there's 5 parts. T represents time measured in seconds. H represents the height measured in meters. So you've got, say, 5 minutes. First one is just substitution. Second one is just substitution of the number that is given to you into the formula. But the last ones are where you have to factorize, and the last part is when you have to do a substitution. So it's in your notes from the last lesson. Okay, so I'll give, say, a 5-minute head start to have a look at it, but we'll do the answers after that. And stop it. So it's going? Okay. So, girls, right out. So first one, again, thanks. First one, can you stop playing with the phone, Elena? Now you've been recorded on that one. Okay, the formula is 30t minus 5t squared. The formula stays the same, obviously. When t equals 0, you got 30 times 0 minus 5 times 0 squared, 0 minus 0. So at t equals 0, the ball is on the ground. M for meters. Because we're measuring something, you have to put a unit. If by chance you forget your units for the whole question, you'll only lose half a mark. You're not going to lose a half a mark every time. Okay, in the second part, it's exactly the same as the first part, except change time 0 to time 2. 30 times 2 minus 5 times 2 squared. Just use your calculator. So at 2 seconds, the ball is at 40 metres. And Mr. Coe can definitely hit the ball 40 metres in the air. But the last 3 questions are the higher level questions. So when the ball is on the ground, it has no height. So h equals 0. So we put 0 out the front, and then we factorize it, and we get 2 answers, 0 and 6. So I'm going to just pause there, and you guys can copy down. Oh, that one? The 2 lines. Okay. So, girls, the last 2 parts. Can you listen? Okay. If the ball's on the ground at 0 and 6, halfway in between those 2 times, the ball is at its highest spot. So halfway between 0 and 6 is 3 seconds. So how do you find the halfway mark? How do you find the halfway mark between 2 numbers? We did do it. We did do it because Mr. Coe hit that.
I've got fun when balls be that.
Yes. Ball is at maximum height in between the time the ball's on the ground. So the ball is at the maximum height at 3 seconds.
Oh, you just read that number.
Yeah. And once you know the time, then you just substitute the time in and find the height of the ball. Once you have the time, substitute and you can find the last part. So the maximum height is 45 meters. And I will pause. Okay, second one, we did this again in that last few lessons, or maybe the last quite. So we've got this exponential growth, and we've got questions like bacteria growing, or we've got radioactive materials decay. So this is the formula that has to be given to you. You don't have to know where it's coming from. So what I want you to do is write the question, leave 3 lines. And I'm pausing. And we're recording. Right. So in the first question, is the population growing or declining? The answer is the population is growing because the power up there is a positive number. It doesn't have a minus sign. It doesn't have a minus sign, so the power is positive, so the population is growing. If there was a minus sign, the population would be declining. Okay? So you look up there, that's top number's positive, it's growing. That's the answer to the first one. So in the next 3, we just substitute the 3 numbers that are given. Oh. So, in the first one, t equals 0. Guys? So you put in t equals 0. The first answer is just the number out the front. And then after that, it's just use your calculator. Bree, can you pay attention, please? Because this is where it's happening. I know. So t equals 0, t equals 0, t equals 2. And the only hard one is the last one where I said the time was in days, but the question said that the time was in hours. So 2 days, turn it to 48 hours, and then substitute the 48. So, can you copy those answers down and face? And we're back to record. Okay, so the last one. Can you watch, please, again? So, the population had to get to 5,000. Now, if you want to, you can just do guess and check, but there's a much easier way. And again, you've got a cheat sheet, so I would just be putting this on my cheat sheet as my example. So 5,000 goes out the front. 5,000 goes out the front. Why does 5,000 go out the front? Because that's the population we want. Then the 700 goes to the bottom on your next line. And then to get rid of E, you take the log. And then to get rid of the 0.05, you divide. So you just do all those steps and you end up with an answer. Go. Okay, so this is our last topic for the unit. So the heading is Graphs and Networks. So I'm going back to record. So there's two types. There's one that have directions, and when I say directions, they have arrows, and ones that don't have arrows. So if they don't have arrows between whatever we're connecting, they're called undirected. Oh, yep. And if they do have arrows, which we're not going to be doing for at least a week or so, if we do have arrows, they're going to be called directed. So everything we do at the start is undirected, and then we do directed later. Okay, so that's the first part. Next step. We're recording now. I'll start naming people's names who are slow riders. close enough. Okay. So the next three words that come up, are vertices, and we've done vertices before because we've done topics with shapes. So vertices are the corners, edges are the lines that join the corners, and the degree of a vertex is how many lines join the edge. So I'm going to say that again. Vertices are corners, they're the things that you're connecting. Edges are the lines that connect the corners, and the degree of a vertex is how many edges join it, and we've got an example coming up in a minute. Back on. So, for instance, here's a map. Who knows what A, B, C, and D is? It doesn't matter, but I've got A, B, C, D. Okay, they're called the vertices. The blue lines, like that's blue to me, I don't know what's blue to you, but those lines, they're called the edges. Alright? So, the only part that's hard is this thing called degree. Now, I know you use the word degree in university and in the hospitality area when you're cooking things, but in this aspect, it's you look at the vertice and how many edges go into that point. There are 3 blue lines not joining, but going into A, so we say that the degree of A is 3.
What's the degree of C?
So what I want you to do is, here's 3 boxes, the degree of B, the degree of C, the degree of D. There are numbers that you put in. Bree, could you tell me what the degree of B is?
2.
Correct. Tori, could you tell me what the degree of C is? Correct. Bronte Lee, I know you've only just come into the class, but what's the degree of D?
2.
Correct. Are there any questions? Because that's as hard as it gets for that part. You like that part? Okay. And changing boards? Back to recording. Okay. So, this is the same diagram. All I've done is I've made it smaller. A, B, C, D. The degree of A is 3, 2, 1, 2. They're the answers that the girls gave us. Adds up to 8. 3 plus 2 plus 1 plus 2 is 8. How many blue lines were there? Okay. You're on tape, Maddie. What's the answer? 4. Okay. Is that okay? There were 4 lines, but the total degree is 8. So the theory is the sum of the degrees is always twice the number of edges. The sum of the degrees is always twice the number of edges. Previous slide, the sum of degree was 8, there were 4 edges. So that's the theory. There's always twice as many degrees as there are edges. Now, so in the second example, down here, which is a completely new one, I've got A, B, C, D done with a lot of crossing over. So, A has 3, B has 3, C has 3, D has 3, which adds up to 12. So straight away, I must have 6 edges. So see if you can find the 6 edges. We got, across the top, we've got 1, 2, 3, 4, 5, 6. So I've got 6 edges. Go again. Just from this side. 1, 2, 3, 4, 5, 6. So I've got 6 edges because I knew I had 12 degrees. Okay. Girls, okay. New notes. Okay. Girls, a connected graph is a graph where you can go to each vertex. If you've got a graph which has vertices and edges, it's called connected if you can get to every vertex. So if some particular classroom or some particular town didn't have a road that got you there, it can't be connected. So just to go through the two examples, the bottom left example, A, B, C, D, there's a road that connects all the vertices, so we call it connected. But in the second example, poor old E is by itself with no road, so it's not connected. Connected, not connected, that's it. Recording. Okay, so next one. Guys watching. So next one has a new word, multiple edges. So in this particular first graph, A, B, C, D, A and B, guys, can you watch physically look up? A and B are connected by two roads. So A and B are joined twice, so we call that a multiple edge. Okay? So if you've got more than two ways of getting to the same spot, that's called a multiple edge. Recording. Okay, and the second word we want to use is the word loop. If you've got an edge, watching guys, if you've got an edge where it connects it to itself, like a circular road, an edge that connects to a vertex to itself is called a loop, so D has a loop. And next slide. Okay, so, girls. Okay, so we're back to, thanks, Bree, you're on tape now. Okay, so when counting the degree of a vertex, because a loop has an in and an out, a loop counts as 2 for that vertex. So for instance, A is okay, doesn't have a loop, but D has 3 lines joining it from the outside, and it has a loop that joins it to itself, so the degree of D is 5. Okay, so that exercise goes with what we've been doing for the whole day today, and it's expected that you'll do it before we see you on Thursday. Okay, on Thursday's class, it's moving on time. We don't have any time for this exercise. You do it yourself. But it's all it is the same skills, plural, that you've just been doing for the last 40 minutes.
They're trying to play.